Hey you guys, how are you doing? This is Angel. Today I'm gonna be tackling another TryHackMe module. So yeah, I just want to keep learning. I remember last time I went through TryHackMe. I was like I had a daily score of I don't know how many days, but they were a lot. They were months, probably around the 200s or 300s. But then I stopped. I was just developing some websites, so I had to just allocate that amount of time to building websites and stuff. But now I'm back, so I want to just continue having this score of a daily discipline to keep my streak in tune. So yeah, that's what I will be doing. Uh, let's go to the screen, guys. Alrighty. So first thing we have to do is I haven't even decided. Although I was looking yesterday at some modules that I might try. I did not decide which yet, so probably I will subscribe to the premium. I just wanted to get through some stuff first, because I was just checking the free modules that they had, and then I was just filtering by high completed. Yeah, some of the most popular maybe, or the newest. I think it was the newest. Okay, so these are some CTFs that I would like to do. I checked this one, which is yes, just a module that I will attack, but not today. It's around 190 minutes approximately. That's the amount of time it should take me to finish this. Well, I'll probably do it in less than that, but yeah, I just want to, I've just been getting back to CTF, so I want to just start doing some walkthroughs, just get familiar again with some terms that I would be using for this pen testing. So yeah, that's that. HTTP request smuggling. Learn about HTTP request smuggling. It's different techniques. Okay, I mean, I guess this sounds interesting to me. What do you want to learn today? Yeah, sure. Let's do that. That sounds interesting. So, okay, HTTP request smuggling. Okay, save room. Sure. No, let's just join. Let's just give it a like, and then let's get through it. Okay, we're gonna have to deploy a machine, so I will quickly just connect. Let's start this machine. I will quickly connect to, this. Let's put this here. Oh, what did I do? Okay, so let's tmux. Then let's create a couple of them. Let's rename this to VPN. Let's go to where my VPN is located, which is here. Then sudo openvpn just to connect to the virtual private network. That's gonna allow me to interact with this machine. So you always have to connect through to the VPN. Everyone knows this, but I'm not gonna go. I mean, everyone familiar with cybersecurity and IT stuff knows how a VPN works. But just for the people that might not be, yeah, this is something I have to do in order for me to be able to connect to the TryHackMe machines. Okay, headphones on. Okay, let's do this. Okay, so the next thing I have to do is, once I've already connected, I want to just have the connection, or just allow this machine to be able to interact with my machine, right? So there is a little script that was developed by, I don't remember the name, guys, sorry, but it basically just basically, yeah, just allows me to connect to this machine and only this machine, and the interaction is going to be both ways. But yeah, nobody else that might be connected to the VPN or just working this machine should be able to interact with my Kali VM. So that's that. So probably sudo, and then the name of the IP that I want to be only connected with. So it's gonna be this one. Put in the password. Okay, so we are on. Let's just test this. So 40.125. Yeah, one received. Okay, so looks like we're connected. Okay, so this, how long is this gonna take me? 60 minutes. Okay, we can do this. Let's do it. Okay, so introduction. HTTP request smuggling is a vulnerability that arises when there are mismatches in different web infrastructure components. This includes proxies, load balancers, and servers that interpret the boundaries of HTTP requests. For example, Consider a train station where tickets are checked at multiple points before boarding. If each checkpoint has different criteria for a valid ticket, a traveler could exploit these inconsistencies to board the train without a valid ticket. Similarly, in web requests, this vulnerability mainly involves the content length and transfer encoding headers, which indicate the end of a request body. When these headers are manipulated or interpreted inconsistently across components, it may result in one request being mixed with another. Okay, so the attacker, this is the front-end server, HTTP post HTTP request, the content length is 44, transfer encoding chunked, and then those malicious endpoint, hostexample.com, same, content time application, this is a form, we are all encoded, and the content length is another one. Okay. Backend server, HTTP also, okay, so then it goes to, then it gets the HTTP response, which should be 200. Okay, so this is the malicious request, and it's okay. So request splitting or HTTP desync attacks are possible because of the nature of keep alive connections and HTTP pipelining. Okay, which allows multiple requests to be sent over the same TCP connection. Without these mechanisms, request smuggling wouldn't be feasible. When calculating the sizes for content length and transfer encoding, it's crucial to consider the presence of carriage, return, and neoline characters. These characters are not only part of the HTTP protocol's formatting but also impact the calculation of content sizes. While testing for request smuggling vulnerabilities, it's important to note that some tools might automatically fix the content length header by default. This means if you're using such tools to run payloads, your content length values might get overwritten, potentially changing the test result. Note that testing for request smuggling can potentially... Okay. So, is there a way for me to... Okay. Yeah. Okay, let's get back to this, guys. Um, Request splitting or HTTP desync attacks are possible because of the nature of keep alive connections and HTTP pipelining, which allow multiple requests to be sent over the same TCP connection. Without these mechanisms, request smuggling wouldn't be feasible. When calculating the sizes for content length and transfer encoding, it's crucial to consider the presence of carriage return and new line characters. These characters are not only part of the HTTP protocol's formatting but also impact the calculation of content sizes. While testing for request smuggling vulnerabilities, it's important to note that some tools might automatically fix the content length header by default. This means if you're using such tools to run payloads, your content length values might get overwritten, potentially changing the test results. Note that testing for request smuggling can potentially break a website in many ways. Cache poisoning, other user requests may start failing, or even the backend pipeline might get fully desynced. So extreme care should be taken when testing this on a production website. Objectives: understand what HTTP request smuggling is and its impact. Identify HTTP request smuggling vulnerabilities in web applications. Exploit these vulnerabilities in a controlled environment. Understand and apply measures to mitigate and prevent these vulnerabilities. Okay. Prerequisites: basic understanding of HTTP protocol and its headers. You can take a look at this room for more detailed explanation. I probably have done this already. Let's see. Yes, I have. Yeah, I do have fair knowledge about HTTP and how it works. Okay. Familiarity with web server infrastructure components like load balancers, proxies, and web servers. Yeah. basic understanding and usage of a proxy tool like burpsit. Okay, importance of understanding HTTP request smuggling. Smuggle requests might evade security mechanisms like web application firewalls. This potentially leads to unauthorized access or data leaks. Attackers can poison web caches by smuggling malicious content, causing users to see incorrect or harmful data. Smuggle requests can be chained to exploit other vulnerabilities in the system, amplifying the potential damage. Due to the intricate nature of this vulnerability, it can often go undetected, making it crucial for security professionals to understand and mitigate it. Deploy the targeted VM to this task by pressing the green start machine button. After obtaining the machine's generated IP address, you can either use our attack box or your own VM connected to TryHackMe's VPN. Okay, we've done that already. Let's keep going. So, modern infrastructure. Components of modern web applications. Modern web applications are no longer straightforward monolithic structures. They are composed of different components that work with each other. Below are some of the components that a modern web application usually consists of. Front-end server. This is usually the reverse proxy or load balancer that forwards the request to the backend. Backend server. This server-side component processes user requests, interacts with databases, and serves data to the front end. It's often developed using languages like PHP, Python, and JavaScript, and frameworks like Laravel, Django, or Node.js. Databases, persisting storage systems where applications data is stored. Examples of this are databases like MySQL, PostgreSQL, and NoSQL. APIs, application programming interfaces. Interfaces allow the front and back end to communicate and integrate with other services. Microservices. Instead of a single monolithic backend, many modern modern applications use microservices, which are small, independent services that communicate over a network, often using HTTP REST or gRPC. Load balancers and reverse proxies. Okay. Load balancers. These devices or services distribute incoming network traffic across multiple servers to ensure no single server is overwhelmed with too much traffic. This distribution ensures high availability and reliability by redirecting requests only to online servers that can handle them. Load balancing for web servers is often done by reverse proxies. Examples include Amazon Web Service Elastic Load Balancing, HA proxy, and F5 Big IP. Okay. Reverse proxies. A reverse proxy sits before one or more web servers and forwards client requests to the appropriate web server. While they can also perform load balancing, their primary purpose is to provide a single access point and control for backend servers. Examples include Nginx, Apache with Mod Proxy, and Varnish. Okay, the user makes a request, then it goes to the load balancer or reverse proxy, then it goes to the server 1, server 2, or server 3, and then the resources are processed on the backend. Okay, role of caching mechanisms. Caching is a technique used to store and reuse previously fetched data or computer results to speed up subsequent requests and computations. In the context of web infrastructure, content caching. By storing web content that doesn't change frequently, like images, CSS, and JS files, caching mechanisms can reduce the load on web servers and speed up content delivery to users. Yeah, indeed. Database query caching. Databases can cache the results of frequent queries, reducing the time and resources needed to fetch the same data repeatedly. Full page caching. Entire web pages can be cached so they don't need to be regenerated for each user. This is especially useful for websites with high traffic. Edge caching, CDNs. Content delivery network cache content closer to the user at the edge of the network, reducing latency and speeding up access for users around the world. API caching. Caching the responses can significantly reduce backend processing for APIs that serve similar requests repeatedly. User, browser cache, CDN cache, server. There's a server cache, that's the database, and there's also the database cache. Caching, when implemented correctly, can significantly enhance the performance and responsiveness of web applications. However, managing caches properly is essential to avoid serving stale or outdated content. What sits in front of one or more web servers and forwards client requests to the appropriate web server? Which was it? A reverse proxy, right? Behind the scenes. Okay. So understanding HTTP request structure. Every HTTP request comprises two main parts: the header and the body. Yeah, this is the header, right? This is the body, and what is this? Okay, sorry. this is the request headers. Okay, let's read through. Request line, the first line of the request. Post admin login HTTP1, yeah, is the request line. Yeah, it consists of at least 3 items. First is the method, which in this case is post. The method is a one-word command that tells the server what to do with the resource. Second is the path component of the URL for the request, the path that identifies the resource on the server, which in this case is admin login. Lastly, the HTTP version number shows the HTTP specification to which the client has tried to make the message comply. Note that HTTP2 and HTTP 1.1 have different structures. Okay. Request header. This section contains metadata about the request, such as the type of content being sent, the desired response format, and authentication tokens. It's like the envelope of a letter, providing information about the sender, receiver, and the nature of the content inside. Okay, interesting. Message body. This is the actual content of the request. The body might be empty for a GET request, but for a POST request it could contain form data, JSON payloads, or file uploads. Content length header. The content length header indicates the request or response body size in bytes. It informs the receiving server how much data to expect, ensuring the entire content is received. Okay, this means that the request or response body contains 14 bytes of data. Okay, so this is measured in bytes. Okay, roger. Transfer encoding header. The transfer encoding header is used to specify the form of encoding applied to the message body of an HTTP request or response. A commonly used value for this header is chunked, indicating that the message body is divided into a series of chunks, each preceded by its size in hexadecimal format. Other possible values for the transfer encoding header include compress, deflate, and gzip, each indicating a different type of encoding. For example, chunked. Okay. In this example, B in hexadecimal, equivalent to 11 in decimal, specifies the size of the following chunk. The chunk Q equals smuggled data is the actual data, followed by a new line. The request is terminated with a 0 line, indicating the end of the message body. Each chunk size is given in hexadecimal format, and the end of the chunked body is signified by a chunk of size 0. How headers affect request processing. Headers play an important role in guiding the server to process the request. This is because they determine how to parse the request body and influence caching behaviors. They can also affect authentication, redirection, and other server responses. Okay, headers, request processing, body parsing, caching, compression, authentication, and redirection. Okay, manipulating headers like content length and transfer encoding can create vulnerabilities. For instance, if a proxy server gets confused by these headers, it might not properly distinguish where one request ends and another starts. HTTP request smuggling origin. Okay, this is what we wanted to know, right? HTTP request smuggling primarily occurs due to discrepancies in how different servers, like a front-end server and a back-end server, interpret the HTTP request boundaries. For example, if both content length and transfer encoding headers are present, ambiguities can arise. Some components prioritize content length, while others prioritize transfer encoding. This discrepancy can lead to one component believing the request has ended, while another thinks it's still ongoing, leading to smuggling. Okay, interesting. Example, suppose a front-end user uses the content length header to determine the end of a request, while a back-end user uses the transfer encoding header. An attacker can craft a request that appears to be a one boundary to the front-end server, but a different boundary to the back-end server. This can lead to one request being smuggled inside another, causing unexpected behavior and potential vulnerabilities. So the attacker is going to send a crafted request with both headers in CL.T ordered. Okay, so then the frontend sends regular response, and then the frontend communicates with the backend, and the backend also processes the smuggled request in the backend, and just basically gets it back to the front end, and then the attacker can actually infiltrate, right? Where request header indicates the request or response body size in bytes. This informs the receiving server how much data to expect, ensuring the entire content is received. Is it content length? Yes. Okay, let's keep going. Request smuggling CL.T. Introduction to CL.T request smuggling. CLTE stands for content length transfer encoding. The name CLTE comes from the two headers involved, content length and transfer encoding. In CLTE technique, the attacker exploits discrepancies between how different servers, typically a front-end and a back-end server, prioritize these headers. For example, the proxy uses the content length header to determine the end of a request, and then the back-end server uses the transfer encoding header. Okay. This is again the same image as we saw before, right? Send crafted request with both headers in CLT order, then gets to the backend, processes smuggle request back to the attacker, sending a regular response, right? Because of this discrepancy, it's possible to craft ambiguous requests that are interpreted differently by each server. For example, imagine sending a request with both content length and transfer encoding headers. The front-end server might use the content length header and think the request ends at a certain point due to the provided number of bytes. In contrast, the backend server, relying on the transfer encoding header, might interpret the request differently, leading to unexpected behavior, exploiting CLTE for request smuggling. To exploit the CLTE technique, an attacker crafts a request that includes both headers, ensuring that the front-end and back-end server interprets the request boundaries differently. For example, an attacker sends a request like post request to this URL. The content length is going to be 130, and the transfer encoding is going to be chunked. And then this is a post request also to the update, and then 13 bytes the content length, and then the content type, and then submit goes through here. The front-end server sees the content length of 130 bytes and believes the request ends after its admin equals true. Okay. However, the backend server sees the transfer encoding chunked and interprets the 0 as the end of a chunk, making the second request the start of a new chunk. This can lead to the backend server treating the post update HTTP as a separate new request, potentially giving the attacker unauthorized access. Incorrect content length. When creating a request smuggling payload, if the content length is not equal to the actual length of the content, several problems may arise. First, the server might process only the portion of the request body that matches the content length. This could result in a smuggled part of the request being ignored or not processed as intended. For example, in the below screenshot, the original size of the body is 24 bytes. Here's 26, okay. To verify that the content length is valid, we can check the submissions directory to verify if the whole body was saved in the txt file. Since the size of the body username equal test, query equal test is 24 bytes, sending a content length with a size lower than this will instruct the backend server to interpret the request body differently. For example, with the content lengths, when the content length is set to less than the actual size of the body, username equal test, query equal test, which is 24 bytes, the backend server will only read part of the request body, and based on the specified content length, okay, so in the size of the body, username equal test, and query equal test is 24 bytes, sending a content length with a size lower than this will instruct the backend server to interpret the request body differently. For example, when the content length is set to less than the actual size of the body, username equal test and query equal test, which is 24 bytes, the backend server will only read part of the request body based on the specified content length. For instance, setting content length to 10 bytes means the server will only consider the first 10 bytes of the body, leading to incomplete data being processed. Yeah, that's not something we want, right? We want to at least put in the same amount of bytes or more if we want to just create a vulnerability and make it think that there's a second request. Yeah, okay, so what does CLTE stand for? It would be, okay, content length, and what was it? Time encoding? Was it time? I'm not sure. Let's check again. Oh, transfer encoding. Huh. Yep. Okay. Let's get back to request smuggling TCL. Okay, this is the same title. Oh, okay, TCL. This is different. Okay, introduction to TCL technique. TL stands for transfer encoding content length. This technique is the opposite of the CLT method. In the TCL approach, the discrepancy in header interpretation is flipped because the front-end server uses the transfer encoding header to determine the end of a request, and the backend server uses the content length header. The TCL technique arises when the proxy prioritizes the transfer encoding header while the backend server prioritizes the content length header. Okay, so the attacker sends crafter request with both headers in TCL order, gets to the front end and gets to the backend for a smuggle request. It works kind of the same way, right? Example, if an attacker sends a request with both headers, the front-end server or proxy might interpret the request based on the transfer encoding header, while the back-end server might rely on the content length header. This difference in interpretation might interpret the request differently, leading to unexpected behavior. Exploiting TECL for request smuggling. To exploit the TECL technique, an attacker crafts a specially designed request that include both the transfer encoding and content length headers, aiming to create ambiguity in how the front-end and back-end servers interpret the request. For example, an attacker sends a request like post request 4 bytes to this there, okay, chunked, and then 78. So in the above payload, the front-end server sees the transfer encoding chunked header and processes the request as chunked. The 78 hexadecimal for 120 indicates that the next 120 bytes are part of the current request's body. The front-end server considers everything up to 0, indicating the end of the chunked message as part of the body of the first request. The backend server, however, uses the content length header, which is set to 4. It processes only the first 4 bytes of the request, not including the entire smuggle request post update. The remaining part of the request, starting from post update, is then interpreted by the backend server as a separate new request. Interesting. Okay, the smuggle request is processed by the backend server as if it were a legitimate separate request. This request includes the asadmin equals true parameter, which could potentially elevate the attacker's privileges or alter data on the server depending on the application functionality. Okay. Transfer encoding obfuscation. Introduction to TE and TE technique. Okay, transfer encoding obfuscation, also known as TET, stands for transfer encoding. Unlike the CLTE or TCL methods, the TET technique arises when both the front-end and the back-end server use the transfer encoding header. In TET technique, the attacker takes advantage of the server's inconsistent handling of transfer encoding present in the HTTP headers. The TET vulnerability doesn't always require multiple transfer encoding headers. Instead, it often involves a single malformed transfer encoding header that is interpreted differently by the front-end and back-end servers. In some cases, the front-end server might ignore or strip out the malformed part of the header and process the request normally, while the back-end server might interpret the request differently due to the malformed header, leading to request smuggling. So the attacker sends a request with double transfer encoding, process first transfer encoding, process second transfer encoding. Okay, and then executes the smuggle request and then returns response for initial part of request. Okay, example. An attacker manipulates the transfer encoding header by including chunked in malformed variations. This is done to explain how front-end and back-end servers prioritize the transfer encoding header over the content length. By crafting malformed transfer encoding headers, the attacker aims to make one server ignore the T header and use CL instead, leading to a discrepancy in how the request boundaries are interpreted between the front-end and back-end servers. This manipulation can result in either CLT or TCL situation, depending on which server falls back to using the content length. Exploiting TET for request smuggling. To exploit the TET technique, an attacker may craft a request that includes transfer encoding headers that use different encodings. Transfer encode. Okay, for example, the attacker sends a request like host example transfer encoding chunked. Okay, for E. Okay, in the above payload, the front-end server encounters 2 transfer encoding headers. Yeah, the first one is a standard chunked encoding, but the second one, chunked one, is non-standard. Depending on its configuration, the front-end server might process the request based on the first transfer encoding chunk header and ignore the malformed chunked one, interpreting the entire request up to 0 as a single chunked message. Okay, the backend server, however, might handle the malformed transfer encoding chunk one differently. It could either reject the malformed part and process the request similarly to the front-end server, or interpret the request differently due to the presence of the non-standard header. If it processes only the first 4 bytes, syndicated by the content length, the remaining part of the request starting from post update is then treated as separate new request. The smuggle request with the admin through parameter is processed by the backend server, and if it were a legitimate server request, this could lead to unauthorized actions or data modifications depending on the server's functionality and the nature of the update endpoint. What does TDD stand for? Well, it's and then a walkthrough. Okay, let's get the flag. Walkthrough. Okay. The vulnerable environment has ATS Apache traffic as the front-end proxy, Nginx as the web server backend, and PHP processing the dynamic content. Due to differences in how ATS and Nginx prioritize content length and transfer encoding header, there is a potential for HTTP request smuggling. Start by adding HTTP request smuggling.thm to your hosts. Okay. Yeah, that's about right. Okay. Okay, already added this to my HC host file. Then assessing the application. The web application for this room uses the link HTTP request to smuggling. It features a home. Okay, I'm not finding this. Why is that? Oh, sorry. I had to link it to this IP address, which I did not do. Okay, then it should work, right? Yes, the develop portal. The website is under development. You may submit your suggestions or feedback in the contact form below. Name and query. Okay. Okay, it features a home login and contact form that enables users to access and send feedback to the developer for demonstration. The submitted queries are saved to the submission directory. Below is a screenshot of the application. Okay, so if I go to the submissions directory, you can see the submissions which turn on currently. Okay, exploiting the application. Using burp suite proxy, interpret the request sent to the website's index. Okay. Let's open burp suite. Intercept a request sent to the website's index. This request will become the baseline we will use to exploit the vulnerable application. Sure. So let's do it. Let's open the browser, intercept sun, then let's go, and then we captured something, right? So let's see. Exploiting the burp suite. Okay, this request will become the baseline we will use to exploit the vulnerable application. HTTP history. Oops, sorry. Yeah, this is what we did get. So this is the request, the HTTP request, the smuggling one, okay. Send the request to intruder and copy paste the below payload to the payload position box. Okay, we'll do that. I just wanted to verify how it's working. Okay, so we have this. So if I go to the intercept, no, okay. So there's a GET request to this URL. There's no size, right? I don't see the size. Content length. Okay, so let's just, I guess, send it to the intruder, as I said, right? So send to intruder. Okay, and then we go to intruder and we get this. Send a request to intruder and copy paste the below payload to the payload position box. Okay, so this is the payload that they want us to use. They've already provided this to us. So if I go to payloads and then, okay, positions. Oh yeah, okay. So they're asking me send a request to copy paste the below payload to the payload positions box. So we will be, I guess, posting this here. Okay, after that, breakdown of the payload. Yeah. Okay, let's see if I can do a breakdown. There's a host, and there's a content type. Content type might differ. Okay, the application of form URL encoded. The content length. This is 160, and the transfer encoding is chunked. Okay, then to specify this, contact.php. Okay, and then the content length changes to 500. Okay, let's see what up. Okay, in CLT vulnerability, since the proxy or the front end prioritizes the content length header, 160 bytes of the body is assumed to be the body. Yeah, of the first post. The front end thinks this is a single request and forwards it to the pipeline, where the backend server now prioritizes transfer encoding and the first post request at the first zero size, chunked, and assuming the second post is a different request. Okay, so you're gonna post to this contact form, payload position box with payload. Okay, and you're gonna post this username and this query. Okay. Okay, payload position box with the payload. Sure, sniper this here. Sure. Go to the payloads tab and set the payload type to null payloads. Payload type to null payloads. Okay. Subsequently, on the payload settings, input 10,000 to generate 10,000 null payloads. Generate 10,000, right? Okay. Go to the resource pool tab and create a new resource pool. You may follow the screenshots below for the settings. So let's go to the resource pool and then and create a new resource pool. You may follow the screenshots below for the settings. Okay, so let's start attack. No, here, create a new resource pool. Custom resource pool 1, sure. Maximum concurrent requests. Then it's gonna be 10, and then delay between requests. Probably 2000, as they said. Fixed, no, with random variations. And then that's it. Click the start attack button in your intruder tab to start the attack. Are you referring to... I guess it doesn't matter which one they click, right? So let's do it. Start attack. Contains a demo version for some function that's disabled, sure. Okay, so what is it that we get? Intruder attack showing all items. Set response 182. Okay, to the start attack. And then, okay, we got this. Or this. Yeah. Checking the response. 200, okay. Okay. This is the cookie. And then this is request to smuggling lab. This is what we get. Request to smuggling. This website is under development. You may submit your suggestion. Sure, okay. After a few minutes, check the submissions website directory to see if the requested content PHP is smuggled containing the request of other users. After a few minutes. Reserving enough minutes yet. Okay. So if I go to submissions, it says my query has been saved. Okay. Okay, again, after. Okay, so if I go here, and I go to submissions, okay, I get it now. So they want us to use that same password, which we should be able to check on one of these text files, but I'm not being able to get to them. So what if I go again? Okay, looks like now I am. If I click on it, I can see something. So what were you saying? Go through the text file to check for the password that was appended to a query parameter. Okay, submissions 2013. Yeah, sure. Login PHP. Okay, I think it just happened that it got my request because it's not accessing the vulnerable application while the smuggling is taking effect will capture my request instead of the request from the target user. Does this mean I will have to do it again? Because there's no login request here. This is just a GET request to this. And the name was test. So, what to do now? Should I run it again? Let's go again to submissions. And then, yeah. Not able to see that, so we can run this again, right? So, we can proxy here. Let's intercept soft, and then let's do it again. So let's just wait a few minutes more before we try to access the submission stuff, but that should do. So let's do it. This is how we do it. Okay, so I'm gonna go to that particular, but I have to turn on the intercept. So I go, okay, so I get this, smuggling, yeah, sure. So let's go to send to intruder, right? Is that it? Was that what you instructed me to do first? Yes, we already configured that. We were able to access that. So now, exploiting using members to intercept a request to send to the will become the baseline we will use to exploit the vulnerable application. Sure. So send the request to intruder and copy paste the below payload. Okay, so let's send this to intruder, and then we go to intruder, and we're able to see this. And what we want. Wait up. I don't think this is what I wanted to intercept. Let's do it again. So this is the website that they are. Okay, so what if I just go here? This is the request that I want to make and the request that I want to intercept. So, okay, is it on? No, it's not. Now it is. Now I go here. Let's make a search for this. Okay, so if you forward. Okay, so this is the request that we were looking for, right? And this is the request that they also sent to the intruder, right? Once they get this request, we can basically send this to the intruder. Send the request to intruder and copy paste the below payload. Sure, send to intruder. Then we go to intruder, and then you were able to see that request. And now we want to just paste this payload. So we do that, and then yeah, since the proxy or the front-end operator is a content length 160 bytes of the body is assumed to be the body of the first post. The front-end thinks this is a single request and forwards it to the pipeline, where the backend server now prioritizes transfer encoding into the first post request of the first zero size chunk, and assuming the second post is a different request. Payload position box with the payload. Okay, so go to the payloads tab. Okay, I'm already here. And set payload type to null type of payloads. Sure. And then on the payload side, is input 10,000 to generate 10,000 null payloads. Sure. Okay, then what else? Go to the resource pool. We go to the pool and create a new resource pool. You may follow the screenshot below for the settings. Sure, so let's do it here. Maximum concurrent requests, this is 10, this is 2000, and then that's that. Oh, this is, I don't want to check this, they did not, but I guess they did implicitly. Click the start attack button in your intruder tab. Sure. Because we can do that. Start attack. Sure. So now we have to just wait a few minutes, right? We're going to be patient here and just wait up a little bit. Takes just a few minutes. And then we check the submissions website directory to see if the request to contact PHP is smuggled containing the request of other users. Okay, so this is the payload. This is what should be smuggled, right? You're making a post request to PHP and you're sending this as a username and the query, this one, which should let's see. What's in your next step? Okay, after a few minutes. Okay, it's not being a minute yet. I'm getting impatient, but as a hacker, you have to exercise some patience sometimes because some things take a while to make effect or take the effect intended. So, to save the requested content, yeah, okay, accessing the vulnerable application. While the smuggling is taking effect, we'll capture a request instead of the request from the target user. Yeah, so you were basically just waiting for the target user to make the request and basically capture their login information, right, with this payload. Makes sense. Okay. Am I understanding everything here? Yes, I think so. This is not something I have done before, to be honest. I have never smuggled an HTTP request this way. But yeah, I mean, you learn something new every day. This is a way to exploit and gain some users' credentials here, right? So let's just give it a one more minute. If I get impatient, I will have to do this again from the beginning. So let's just exercise patience. 48, okay. And this is it, right? So I should get the flag from here and then the conclusion. Yes. So let's try it now. If I go here, okay, I do see another text file. Hopefully this is not from my request. Oh yeah, you see, we got it. Okay, so yeah, go to the text files, check for the password that was appended to the query parameter. And I think this was the password, right? And the name was test. Yeah, okay, use the password to log into the application. Sure. What? So I want to log in using that password, but I don't want to lose it from my... Okay, so I think the name was test. What? Oh yeah, log in here. What do you mean? Oh, okay. Okay, wait up. So go through the text to check the password that was appended to the query parameter, which I already got. Use the password to log in to the application. Okay, that's what I'm trying to do, but you're not quite letting me. Okay, developer login. Now I paste the password. Don't save. Okay, now it's working. So, okay. So we can do this. We got the flag. We submit the flag. Then we go through the conclusions. So conclusion, HTTP request smuggling occurs due to differences in interpreting request headers by servers, mainly through the manipulation of content length and transfer encoding headers, leading to unclear request boundaries. This can cause servers in environments with both front-end and back-end components to incorrectly define request limits, potentially allowing security bypasses and unauthorized data access. Mitigation approaches, uniform header handling. Ensure all servers handle headers in the same manner to prevent smuggling opportunities. Embrace HTTP2. Switching to HTTP2 can enhance the management of request boundaries, reducing the risk of smuggling. Okay, it's important. Ongoing surveillance and reviews. Keep an eye on server traffic for smuggling signs and perform periodic checks to maintain secure server setups. Team awareness. Make sure both development and operations team understand the dangers of request smuggling and the preventive measures. To summarize, despite the significant risk posed by HTTP request smuggling, it is a manageable issue with the right knowledge, strategies, and resources. Emphasizing security in web application development and management is crucial for protecting both the application and its users. I can now exploit HTTP request smuggling vulnerabilities. Sweet. And that's it, guys. Thank you for staying with me. Yeah, this should be everything. Peace, guys.